Hello, welcome back to De La Cruz Engineering videos. So for today, we'll be having unsymmetrical parabolic curve under surveying and transportation engineering. Okay, so our problem for today will be solved using two approach, the grade diagram and the conventional derived formula for unsymmetrical parabolic curve. Okay, so if you haven't subscribed to our channel yet, please consider to subscribe and click that bell icon in order for you to be notified if ever we have new videos. Okay? So without further ado, let's read our problem. An unsymmetrical parabolic curve has a forward tangent of negative 8% and a backward tangent of positive 5%. The length of the curve on the left side is 40 meters, while on the right side is 60 meters. PC is at station 6 plus 780, and the elevation of that is 110 meters. So determine the elevation at station 6 plus 820, and also determine the elevation at the summit. Okay, so first we'll be using the grade diagram to calculate the difference in elevation. Okay, so if these are the tangent lines, this is the forward tangent and this one is the backward tangent. Okay, so basically, this one is our negative 8% and this is positive 5%. Okay, so it will be connecting two vertical symmetrical curve, or basically it connects two parabola. Okay, so this will be the first parabola or the first symmetrical curve, and this is the second parabola. So by the way, the unsymmetrical parabolic curve can be two or more parabola. Okay, but most commonly for the problems we take, we only have two parabolic curve. Okay, so this is L1 and this is our L2. Okay, so if we draw a tangent line at this point below the PI, the tangents of this one will meet halfway. That's why it is L1 over 2 and this is L2 over 2. So this is the grade of the common tangent, and we call that grade there as G sub 3. The grade at this point, no? At the point of common curvature. Okay. So we have there at elevation, the station of PC is 6 plus 780, and of course we have the elevation there. Okay, now notice that the stationing of 6 plus 820 will just fall under PI. Okay, this is our station 6 plus 820. By just considering that the difference of 820 and 780, that is equal to 40 meters. Okay, so for part 1, we just need to have the difference of elevation between PC and this point here. And let us call that one as point T. Now, we'll draw the grade diagram. Okay, so we have here our neutral line. So to construct the grade diagram, we just need the 3 points since this is unsymmetrical parabolic curve. So the first point, of course, that will be the PC. The grade at PC, that is positive 5%, that is above the neutral line, no? That is 0.5. So this is our point. Okay. Now next, we have here the grade at PT. So that is negative 8%, the forward tangent. Okay, below the neutral line. This one. Okay. Now, since this is unsymmetrical parabolic curve, we need to know the value of G3. Okay, so take note, G3 is not given in the problem. So how do we solve the G3? So in this figure, as you can see, that is going downward, no? But in reality, we are not sure if this is going downward or that is going upward. So we can check that one using the formula, if that is positive or negative G3. It can be here above or it can be here below. So we need to check that one. And let me take you back to this figure here. To calculate the G3, we just consider this figure dito. So notice that the vertical offset distance from PI to the PI of the first curve, that is just the grade G1 times L1 over 2, considering this triangle. Okay? Now, on the right side, the vertical offset distance from PI to the PI on the second curve, that is G2, the grade of this tangent times L2 over 2. Now, considering this grade, the grade of this from PI of the first curve to the PI of the second curve, that is the G3. Okay? Now, notice that L1 plus L2 is equal to the total length of the curve. Okay? That means this L1 over 2 plus L2 over 2, that is just simply L over 2, or the total length of the curve divided by 2. So that's why we can have here the vertical offset distance from PI of the first curve to the PI of the second curve, that is G3 times L over 2. Okay? So simply, G3 is just equals to the difference of this vertical offset distance, G1 and G2. So generally, we can have it here, G3 times L3 is equals to the arithmetic sum of the vertical offset distance, G1, L1, G2, L2. May 1/2 yan, but we can just factor out the 1/2, then cancel that one. Okay? So this is the general formula. Of course, one of these two grades must be negative. So by the way, this is applicable also if the curve is downward or sag curve. Okay, this is also applicable. All right. So let's calculate first the value of G3 before we have our grade diagram drawn. Okay, so we have here our G1, that is G1 is 5%, sorry. G1 is 5%. Okay, G2 is negative 8%. That is negative 8%. Okay, so using the formula I have shown you lately, G3 can be calculated is equals to, so G1 is 0.05, L1 is 40 meters. Okay, we have here L1 plus G2 is negative, so that is negative 0.08. We need to consider the sign there. L2 is 60 meters divided by L1 plus L2, or the total length, no? That is 40 plus 60. That is the total length, or the L. So we have here our G3 as negative 0.28. Okay? Now, as you can see that the G3 is negative 0.028, we can now plot our grade diagram. G3 is below the neutral line. It is somewhere here. So connecting these lines here, then this is our grade diagram. All right? Okay. So to calculate the elevation at T, since we have the elevation of PC, we need to calculate their difference in elevation. So let me call this one as Z, the difference of elevation of T and PC. Okay? Now that Z is just equals to the area on the grade diagram under these 2 points. So basically, this shaded gold, that is the area we need to calculate equivalent to Z. Okay? Now, as you notice that the areas here have positive and negative area. So by the way, this becomes a negative area because G3 is negative. Okay? So we need to add this area, the positive and negative area, then that will be our Z. All right? Okay, so since we have the value of Z, so of course we need to have the distance, no? The distance of this triangle. So at this point, by the way, notice that when the grade is 0, that represents the summit or the peak point or the highest point of the curve. Okay? So let me call that one as point S. Okay, so we need to calculate the distance here. Let me call that one as small s to have the areas of these grades. Okay. So that S can be calculated by ratio and proportion. Okay? So by ratio and proportion, so we have there S is to G1, S is to G1, 0.05 is equals to, let's have the total length of this triangle. We can just consider a big triangle here. So that is L1. Okay, L1 over the total grades, no? The total vertical grades, that is 0.05 plus DG3. Okay? So take note, we already calculated the G3. So simplifying this one to calculate the value of S, I mean, correct the S, no? Just copy this one. And take note that L1 is 40 meters. Then cross multiply 0.05 the G1. Then I will just substitute the value of G3. G3 is 0.028. So by the way, in ratio proportion, we just need to have the absolute value of the grades here. Okay, because we just consider this one as a line. This is just geometrical analysis. So the S, of course, the unit must be in meters. S is 25.641. And the summit is truly behind the point T. Okay, it is on the left side. Now we have the value of S, then calculate the Z, which is the area. This Z is just the area of this grade here. Okay, so Z equals to the area of the first figure here is 1/2 or 0.5 of base. Base is S times height is G1. Okay, now the next curve that is the same triangle, the same that is a triangle. Now the base of this triangle here is this one, that would be L1 minus S multiplied by, of course, that is G3. Okay, so we just need to substitute. The value of S is this one. All right, I'll just substitute the values there. The value of G1 is positive 0.05. Okay, the value of L1 we have there 40, and the value of G3, that is negative 0.028. Okay, so we need to consider this negative sign here because this will tell that this area, this whole area here is negative. The grade will indicate if the area is negative. Okay, so the unit for this one must be in meters. All right, therefore the value of Z is equals to 0.44 meters. Now, we can now calculate the value or the elevation of point T. So the elevation of point T, as you can see, that would be the elevation of PC plus Z, the difference in elevation. So notice that this is positive 0.44. So positive area or positive change in elevation indicates that the second point is elevated than the first point. Okay? If this becomes negative, that means the second point is below the first point we considered. Okay? Anyway, this should be 110 meters. Z is 0.44. The unit here must be in meters. The answer here is 110.44 meters. Part 1. Okay? Now, for part 2, the elevation of the summit. Summit is the peak point or the highest point of the curve. Now, as I have said lately that the summit, the location of the summit is where the grade is 0. So at this point, this is the summit point and I call that one as station S. So to have this, we just need to have the area under these 2 points. No? Our basis is our PC since the elevation at PC is given. We can also take the area of this to calculate since we have the elevation at T, then we can also take this area to have the elevation of S. Or we can also have this area to have the elevation of S. Let's try to do the two. Okay? Now, to have the elevation of S, considering the PC, so the area for this is the difference in elevation. Okay? So, let me call that one as A, the difference of elevation between S and PC. So, that A here, the small a, is equivalent to the area of this portion, the area under these 2 points. Alright? So, the A is equals to 1/2. Actually, that area there is just equals to this area here. Okay, the positive area, we already calculated. Let me just copy that one to be fast. Okay, that should be in meters. That is 0.641. Therefore, the elevation of the summit or elevation of S is equals to the elevation of PC plus A. So, notice that A is positive because point S is higher than PC, or the second point is higher than the first point. Okay, anyway, substitute 110. A is 0.641. Of course, the unit is in meters. That is 110.641. This is part 2. Okay? Or as I have said, since we know that the elevation of T is given, or we already calculated the elevation of T, so pwede rin gamitin natin yung difference of elevation between S and T. Okay. So, alternative solution, or we can have it here, let's say, difference of elevation between S and T. I'll just call that one as delta ST, no? So, that would be the area between these 2 points. Basically, this negative area. And that negative area there is just equals to this. We already calculated that. Alternative solution. Okay? So, that would be negative 0.021. As you can see, that is negative. That means that the second point, which is in this case, we consider S and T, the second point or T is below station S. Okay? That's the indicator. Therefore, we can have it here, the elevation of S, okay? That would be equal to the elevation of S plus the delta of ST is equals to elevation of point T. That one. Okay, so just transpose that one there, then it will become elevation of S is equals to elevation of T. The elevation of T is 110.44. Then we just transpose this one here to the right, that will be minus, but take note that this is negative, so minus 0.201. Okay, or simply we can have it here, point T plus the difference of elevation equals S. As you notice, negative times negative is positive. Okay, so that should give us the same answer, 110.641, same as here. Okay, anyway, you can just do this one, or simply understand the solution. Okay, so this is using the grade diagram approach. Now we can have the conventional formula, derived formula to calculate the difference in elevation. Okay, so the only formula we need to memorize is the value of the vertical distance from PI to the, what is this? To the curve. Okay, now notice that if you want to calculate the elevation at point T, given elevation of PC, considering this triangle here, the elevation of PI is equal to elevation of PC plus G1 times L1. Okay? The vertical offset distance. So if you have the elevation of PI minus H, that would be the elevation of T. That is very simple. Okay? So to do that, the formula we need to memorize for this is the value of H. The vertical distance from PI to the curve is given by this formula. H is equals to L1 this is the formula to calculate the value of H. This is for specifically unsymmetrical. Okay? For symmetrical curve, we have also a formula for the value of H. Specifically, this is for unsymmetrical curve. Alright. So, actually, this can be derived using geometry, no? But I will not do it here because this will take time to derive these formulas. Okay? So, calculating the value of H there, that would be okay, let me just copy this one. L1 is 40. L2 is 60. If there's 60, G1 is 0.05. G2 is negative, no? That is negative 0.08. L1 is 40. L2 is 100. The unit for this is in meters. Then H is 1.114 meters. Okay? So, if this happens that this is negative, then the curve is going down, or that is a sag parabolic curve. Okay? If this is positive, then the curve is a summit going up. Okay, anyway, so calculating the elevation of PI, that would be the elevation of PC plus the vertical offset distance of PI to PC. So that would be G1 times L1. Alright, G1 times L1. So substitute, we have elevation of PC 110 meters. G1 is positive 0.05. Then L1 is 40. Okay? Therefore, the elevation of PI is 112 meters. Okay? Now, the elevation of T is 112 meters, PI minus the value of H. 112 meters, elevation of PI minus the H. H is 1.114 meters. Of course, the unit is in 110.886. Sorry. This is 60 meters. Sorry for that. Okay? I didn't notice this error. So, H is 1.56. Let me just change this one. 56. Okay. 110.44. Alright? So, this is the same what we calculated using the grade diagram. 110.44. Okay, how about the elevation of the summit? So, for the elevation of the summit, as you can see, I call this one as point S. S prime, no? Station S prime. On the grade, on the tangent line. This is the elevation of S on the curve. So, to calculate this one, I just need to have the value of Y. That one. Okay? Of course, we also need the value of this S. So, S or the distance can be always calculated using the grade diagram. Okay? But to calculate the difference in elevation, we can just take the value of Y. Therefore, first we need to calculate the elevation of S prime, considering the vertical offset distance of S prime and PC. If we have the value of S, then minus Y, then that would be the value of elevation of the summit S. Okay, so how do we solve the value of Y? So the value of Y can be calculated using the SPP, or the square property of the parabola. Okay, so by square property of the parabola, by SPP, we can have it here, Y is to the length, Y is to the length to PC, that is S squared, okay, is equals to H, this H to the length, I mean to the PC, length of PC, from PI to PC, that one. That is L1 squared. Okay, that is just square property of a parabola. Now, if you want to take the vertical offset distance from the tangent to the curve on the right side, then we'll be considering the base for that is our PT. So Y, for example, this Y is here, Y to PT is equals to H to PT squared. That one. Okay, anyway, so in this case, we can calculate the value of Y since we have the value of H. Okay, so again, we need to just memorize this formula. This one formula lang. Okay, and the other can be calculated using the grade diagram or the basic formula, I mean basic principle on geometry. Okay, value of Y is equals to H over L sub 1 multiplied by S 1 squared. Sorry, this is squared. Okay, so H is 1.56, L1 is 40, and S1, what is, I mean, this is S. What is the value of S? So we calculated that, and that is 25.641. Close this one to a parenthesis. Okay, so the unit for this, that should be in meters, is 0.641. Okay, so first calculate the elevation of S prime. Elevation of S prime is equals to the elevation of PC plus the vertical offset distance from PC to PI to S prime. That one. Okay, that would be G1 times S. I hope that is clear. Take note, elevation of PC is 110, G1 is 0.05, and S is 25.641. The unit is in meters. Okay, now we can have the elevation of the summit S. The elevation of S is equals to elevation of S prime minus Y. Okay, this is 111.282 minus Y is 0.641 in meters. That is 110.641 meters. Okay, now let's check, no? This is what we solve using this approach. How about the grade diagram approach? That is 110.641, or this one. Okay? Alright, so this will end our video. I hope you learned something from these tutorials. And please continue to support our channel uh, to help me also. Okay? So thank you for watching.